All right, let's read example number 7. So now example number 7 asks us to find the boundedness of these two functions. Well, one way we could find the boundedness is to simply graph it, right? I could just plug this in my graphing calculator and then figure it out from there. Another way to do it is algebraically. So let me write these down. I'm going to find the boundedness of the function 3x squared minus 4, and then the boundedness of another function, which is x over 1 plus x squared. And so I just basically wrote those functions down. All right. And so what we're going to do is we could graph this, and then we've got to kind of show why it's bounded algebraically. Okay, so I have the two functions listed there. Well, the first thing I want to do is look at them graphically. Okay, so I'm going to pull up my graphing calculator, and I'll do the first one first. So I'm going to say 3x squared minus 4, and let's graph it. All right, looks like it's bounded from below, right? So right away I'm going to say bounded below. Not that hard. How long did that take me? Time me. That was what, 10 seconds to plug it in the calculator? Yeah. Now how do I prove that algebraically? Well, let's look at this. It has a minimum value. So what we can, one thing that the textbooks suggest is that we could do this algebraically, but I could find the minimum value graphically, right? So if I hit second trace, that pulls up the calculate menu. That's clearly a minimum. I'm going to go minimum. Left bound means I need to go a little bit to the left of the minimum value. So I'm going to bring my calculator around. It looks like it's a minimum value close to 0. So I'm going to go a little bit to the left of that. Right, and I'm going to go a little bit to the right of that, and I'm going to try and get this as close as I can to the bottom. And it's not quite 0, but it's pretty close, right? And what's the minimum y value though? That's what we're really interested in. -4, right? So what we're finding here is that this is -4 is the lower bound. Okay? Does that make sense? Now let's do this again for the other function. And that's it. That's all the textbook wants us to do. Later on I'll show you guys, especially in calculus, I'll show you, and when you take calculus, we'll show you how to solve that out. Well, I shouldn't say algebraically, you actually use calculus, but there's ways that I could find that mathematically, okay? Well, you could do it on the calculator too. If I were to go in here and look at the table of values, right? What are the y values doing as I scroll down? They're decreasing, right? Decreasing, decreasing. Now at this point what happens? They're increasing, increasing, increasing. So that's the relationship between increasing and decreasing. So if a function's continuous, right, and it's increasing, and then it goes from increasing to decreasing, or in this case it goes from decreasing to increasing, that's a bound, that's a boundary, right? And so you could look at all the values, which is the same as looking at the graph, and that's another way to determine that. So let's go in here and try to do the second one. So the second one is x divided by the quantity 1 plus x squared. Now, we'd never want the denominator to equal 0. However, because x is squared and we're not subtracting that value, you're going to have 1 plus a positive value. So will the denominator ever equal 0? Never. Never. If I plug in 0, it'll be 1. If I plug in 2 for x, it'll be 1 plus 2 squared, which is 5. If I plug in -10, it'll be 1 plus -10 squared, which is 100, right? Which will be 101. So when I graph this, I'm never going to have 0 in the denominator like I do sometimes. But I've got like this funny graph, and so what I'm going to do is I'm just going to zoom in a little bit, get a better look at it. Let's zoom in. Let's do the Y window. I can't see the Y's very good, so I'm going to change this from -3 to 3. See what we get. And so I'm going to graph it. All right. So this is bounded from above and bounded from below. Now, do you guys know how I could solve that? Same way. The exact same way. I can come in here and I can hit second trace. It looks like there's 2 maximum values. I don't know where it is exactly. So I could come in here and try to find the maximum. This looks a little bit to the left. This looks a little bit to the right. I'm going to try to guess in the middle. Looks like 1/2, right? So this would be 1/2 is the upper bound. What do you guys guess the lower bound would be? It might be. So let's see. Second trace. Now we're going to find the minimum. So I'm going to go a little bit to the left of this hump here, and I'm going to hit enter, and then I'm going to go a little bit to the right of the hump, hit enter, and I don't know, this looks good right here. -1/2 is the lower bound, right? Any questions?